Hi students, welcome back to Lucky Naresh Physics channel. Students, today I am going to launch JEE Mains Physics Booster. In this session I am going to discuss about JEE previous year questions from moving charges and magnetism. Let us start the class. Moving charges and magnetism. JEE Mains previous year questions. See the first question, my dear student. See, my dear student, here the first question. A solenoid of 1000 turns per meter has a core with relative permeability 500. Insulated windings of the solenoid carry an electric current of 5 ampere. The magnetic flux density produced by the solenoid is given permeability of free space, that is 4 pi into 10 power minus 7 Henry per meter. This was given in 2021, my dear student. Then what are the options they have given? Look at here. Option A, pi Tesla. Option B, 2 into 10 power minus 3 pi Tesla. Option C, pi by 5 Tesla. Option D, 10 power minus 4 pi Tesla. Now we will do solution, my dear student. Solution. See, first of all, it is a solenoid, my dear student. The strength of the magnetic field inside a solenoid is, that is, B is equal to mu Ni, where mu means permeability of medium, N means number of turns per unit length, I means current, my dear student. So, my dear student, here instead of this permeability of medium, I will write this in terms of relative permeability and permeability of free space, and instead of this small n I will write capital N by L, that means total number of turns per total length. Look at here, my dear student. So here we got B is equal to mu naught mu R, capital N by capital L into I, my dear student. My dear student, now I will substitute the values of mu naught mu R, N by L and I. Look at here, my dear student. Then what I will get? See, mu naught means 4 pi into 10 power minus 7, okay, into mu R means given relative permeability 500, my dear student, so into 500, so into number of turns 1000, total length, that is 1 meter, my dear student, by 1, current 5 ampere, so I wrote 5 ampere. So if I simplify means, then I will get pi into 10 power minus 7 into 10 power 7. 10 power minus 7 into 10 power 7 means 10 power 0 you will get, that means 10 power 0 means 1, so pi into 1 you will get pi Tesla, my dear student. So that's about this problem. So if you check the answer from the options, option A is the answer, my dear student. Now we will go for second problem, my dear student. See, my dear student, second problem. A hairpin like shape as shown in figure. See, my dear student, one figure is there here. It is look like hairpin, my dear student, which carries current, my dear student. Okay, so in this hairpin like structure, current is flowing, my dear student. Okay, so here a hairpin like shape as shown in figure is made by bending a long current carrying wire. So here one current carrying wire is bent in the form of hairpin, my dear student. Okay, so here what we have to find? What is the magnitude of magnetic field at point P, which lies on the center of the semicircle, my dear student? So we have to find magnitude of magnetic field at point P, which lies on the center of the semicircle, my dear student. It was given in 2021, my dear student. Now, what are the options given? Look at here. Here the options, if you see, option A, mu naught I bracket of 2 minus pi by 2 pi r. Option B, mu naught I bracket of 2 plus pi by 4 pi r. Option C, mu naught I bracket of 2 minus pi by 4 pi r. And option D, mu naught I bracket of 2 plus pi by 2 pi r. Now we will do solution, my dear student. See, solution. Before doing solution, we will check the figure once. See here, from the figure, if you see, means here the upper portion is one end infinite, other end is finite. Okay, and the middle portion semicircle, and the lower portion one end finite, other end is infinite, my dear student. So my dear student, due to upper portion, the strength of the magnetic field is B1, that is at point P into the plane. Okay, if you apply right hand thumb rule, you can get that. Then due to semicircle, at point P, the magnetic field strength is B2, that is also into the plane. Due to lower part, the magnetic field at point P, that is also into the plane, my dear student. So here all are in same direction. So the net magnetic field is B is equal to B1 plus B2 plus B3, my dear student. Okay, now I will substitute in the place of B1, B2, B3. Okay, my dear student, see, now I will substitute in the place of B1, B2, B3. Then what I will get? See, in the place of B1, I got mu naught I by 4 pi r. My dear student, see, if you observe here, the upper part is one end infinite, other end finite. Due to this upper part, the strength of the magnetic field at point P is mu naught I by 4 pi r. Okay, and due to second part, that is semicircle, due to that semicircle at point P, the strength of the magnetic field is mu naught I by 4 r, my dear student. And due to lower part, as is like upper part, that is mu naught I by 4 pi r. So here I will add mu naught I by 4 pi r plus mu naught I by 4 pi r. Then I will get 2 mu naught I by 4 pi r plus remaining term, that is mu naught I by 4 r. Okay, now my dear student, I will write mu naught I by 4 pi r commonly outside. See why I wrote, means here in the options mu naught I by 4 pi r is there. So I will write commonly outside. Then what I will get, my dear student? Look at here. Then I will get mu naught I by 4 pi r if I write commonly outside. Inside the bracket I will get 2 plus pi, my dear student. So if you check the options, the answer is, that is option B is the answer, my dear student. That is mu naught I bracket of 2 plus pi by 4 pi r, my dear student. Now we will discuss about next problem, my dear student. So here the next problem. Magnetic fields at 2 points on the axis of a circular coil at a distance of 0.05 meter and 0.2 meter from the center are in the ratio 8:1. The radius of coil is, my dear student, here one circular coil is there. Okay, so at a distance 0.05 meter from its center on the axis, okay, and 0.2 meter from the center, okay, on the axis, the ratio of magnetic field is 8:1. So you have to calculate the radius of coil, my dear student. So it was given in 2021, my dear student. Okay, now we will observe options. What are the options they have given? See, my dear student, options here. Option A 0.15 meter, option B 0.2 meter, option C 0.1 meter, and option D 1.0 meter. Okay, so my dear student, here we will observe the solution now. See, before observing the about solution, we will check the figure. See, figure here. See here, my dear student, it is a circular coil. Okay, the first point is 0.05 meter, that is I consider as x1. So at a point on the axis, the strength of the magnetic field is B1, which is at a distance x1, that is 0.05 meter, my dear student. And the second point is at a distance 0.2 meter, that is x2. Okay, at which the strength of the magnetic field is B2, my dear student. Here B1 is to B2, they have given 8:1, my dear student. So we have to calculate here radius of this circular loop. Okay, so now we will do the solution, my dear student. See, my dear student, it is circular loop. Okay, the strength of the magnetic field at a point on the axis of circular loop is, that is B is equal to mu naught NIR square by 2 bracket of r square plus x square whole power 3/2, my dear student. Here mu naught means permeability of free space, n means total number of turns, I means current, R means radius of circular loop, X means distance of point, my dear student. See, my dear student, in this given equation, N constant, I constant, mu naught constant, R also constant. What is variable here? X is the variable. See, we are calculating, that means strength of the magnetic field at 2 points, that is x1 and x2. So X is variable, my dear student. So from this, if I write proportionality relation, what I will get? See, that implies B inversely proportional to 1 by root over r square plus x square whole power 3 by 2, my dear student. Okay. So from this I can write B1 by B2 is equal to r square plus x2 square whole power 3 by 2 by r square plus x1 square whole power 3 by 2. That implies, that means that is equal to what we will get, r square plus x2 square by r square plus x1 square whole power 3 by 2. Okay. So here I multiply with 2 by 3 on both sides with powers 2 by 3. Then what I got? I got B1 by B2 whole power 2 by 3 is equal to r square plus x2 square by r square plus x1 square. So my dear student, here they have given B1 is to B2 is equal to 8 is to 1, my dear student, and x1 is equal to 0.05 meter, x2 is equal to 0.2 meter. I will substitute this in the above equation. Then what I will get? Look at here, my dear student. I will get 8 by 1 whole power 2 by 3 is equal to r square plus x2 plus 0.2 whole square by r square plus x1 plus 0.05 whole square. Then my dear student, if I simplify means what I will get? I will get 8, I wrote 2 cube. So 2 cube whole power 2 by 3, that is equal to r square plus 0.2 whole square means 0.04, my dear student. Then by r square plus 0.05 whole square means 0.0025, my dear student. So my dear student, so next 2 square means 4. This 3 cancel, we will get 4 here. That is equal to r square plus 0.04 by r square plus 0.0025. That implies 4 bracket of r square plus 0.0025 is equal to r square plus 0.04. My dear student, if I simplify means I will get 3r square is equal to 0.04 minus 0.0100, that is equal to 0.03. That implies r square is equal to 0.03 by 3, that is equal to 0.01 you will get. So if you want to find r means we have to move square to the right side, then you will get r is equal to root over 0.01, that is equal to 0.1 meter, my dear student. So we got radius 0.1 meter, my dear student. So from the given options, the answer is option C, my dear student. That's about this problem, my dear student. Next we will go with another problem. See, magnitude of magnetic field in SI units at the center of hexagonal shape coil. See, my dear student, here the coil is hexagonal shape, that means it has 6 sides. Okay. See, upside 10 centimeter, that means each side 10 centimeter. 50 turns, it has 50 turns, my dear student, and carrying current I in ampere. Okay. We have to write this magnitude of magnetic field in units of mu naught I by pi is. So my dear student, they are asking magnitude of magnetic field at the center of a hexagonal shape coil, offside 10 centimeter, 50 turns and carrying current I in units of mu naught I by pi is. That means we have to find magnitude of magnetic field in terms of mu naught I by pi. Okay, it was given in 2020, my dear student. Then what are the options they have given? See, my dear student, they have given options. Option A 500 root 3, option B 250 root 3, option C 50 root 3, option D 5 root 3, option D 5 root 3. So my dear student, so what is the solution? See, we will check the solution here. Look at here, my dear student. Before doing solution, we will observe figure, my dear student. Here it is hexagonal shape coil. See, I will observe the figure here. See, we will check the figure here. See, here it is hexagonal shaped coil which has 6 sides. Hexagonal means it has 6 sides, my dear student. Each side is A, my dear student, here. So we have to find strength of the magnetic field at the center of this hexagonal in terms of mu naught I by pi. Okay, my dear student, here I am considering one side here. Okay, that side is a finite conductor. Okay, the point C, which is center of hexagonal, which is at a distance r from this side. Okay, so my dear student, which is at a distance r. Okay, so for finite conductor at point C, okay, what is the formula for finding strength of the magnetic field? Here, my dear student, here if I join the ends of this finite conductor with this point C, okay, that sides making an angle 30 degrees with radius here. Lower one also 30 degrees, my dear student. So here alpha 30 degrees, beta 30 degrees. So my dear student, what is the formula for finding strength of the magnetic field? That is, for finite wire, okay, at a point C, the strength of the magnetic field is mu naught I by 4 pi r bracket of sin alpha plus sin beta, my dear student. So here alpha beta plus I will write 30 30. See, my dear student, I will show the formula here. So see, my dear student, here we are finding for 6 sides, okay, and number of turns also we have capital N, that means 50 turns. So if I substitute all this, what we will get? See, strength of the magnetic field at C, N into 6 into mu naught I by 4 pi r bracket of sin 30 plus sin 30. My dear student, here for one side we have mu naught I by 4 pi r sin 30 plus sin 30. We got this one from this formula, that is B is equal to mu naught I by 4 pi r bracket of sin alpha plus sin beta. See, my dear student, this is for one side. For 6 sides you have to multiply with 6, okay, and total number of turns, that is capital N, you have to multiply with N, my dear student. Now if you substitute all this, then in the place of N we have to substitute 50 turns, and here R means distance of point from this side in this equilateral triangle. R means height of this triangle, so that is root 3 by 2a. R means, see, my dear student, here N means 50 turns, R means root 3 by 2a. So root 3 by 2 into A means side here. How much they have given? They have given 10 centimeter, my dear student. That is 10 into 10 power minus 2 meter. I converted into meter. So I got root 3 by 2 into 10 power minus 1, my dear student. Now I will substitute all this in the above equation. Then what I will get? See, sin 30 means you know that 1 by 2. Okay, that all I will substitute here. Look at here. Then what I will get? So here I will get 50 into n plus 50, 6 only, mu naught I by 4 pi. In the place of R, I have to substitute this root 3 by 2, 10 power minus 1. So root 3 by 2 into 10 power minus 1, I have to substitute in the place of R, which is in the denominator, and its reciprocal will be 2 by root 3 into 10, my dear student. Then bracket of sin 30 means 1 by 2, this sin 30 also 1 by 2. So my dear student, here 1 by 2 plus 1 by 2, 1 we will get. Then if you simplify means, then we will get 50 into 6, I wrote 2 into 3 into mu naught I by 4 pi, 2 by root 3 into 10. Why I wrote 6 as 2 into 3, my dear student? Here if you observe means in all options we have root 3. So if I write 2 into 3 means this root 3 cancel this 3 root 3 times, then I will get root 3 in the answer. Okay. So that's why I wrote 6 as 2 into 3, my dear student. If I simplify this, then I will get 50 root 3 mu naught I by 4 pi, my dear student. So I got magnitude of magnetic field 50 root 3 mu naught I by 4 pi. That is in terms of mu naught I by 4 pi I got magnitude of magnetic field. So my dear student, if you observe the options, answer option C is the answer. So my dear student, option C is the answer. So that's about this problem, my dear students. Next we will go with another problem. Yeah, my dear student, a wire A bent in the shape of an arc of a circle carrying a current of 2 ampere and having radius 2 centimeter, and another wire B also bent in the shape of arc of circle carrying a current of 3 ampere and having radius of 4 centimeter are placed as shown in the figure. Okay, see here figure, see here one figure is there. So in that wire A we have and wire B we have. Wire A is bent in the shape of an arc, my dear student, okay, which is carrying current 2 ampere, okay, whose radius is 2 centimeter, and wire B also bent in the shape of arc, my dear student, see in the shape of arc, okay, carrying current 3 ampere and having radius 4 centimeter, okay, are placed in figure, okay. So what you have to find, the ratio of the magnetic field due to wires A and B at the common center O is, we have to find ratio of magnetic field due to this wire A and B at the center O. It was given in 2020, my dear student. Now what are the options? Options here 2:5, option A 2:5, option B 6:5, option C 4:6, option D 6:4, my dear student. Then we will do solution, my dear student. See, my dear student, see for any sector, okay, or any circle, okay, the magnitude of magnetic field, okay, at the center is B is equal to mu naught I by 4 pi r into theta, my dear student. Okay, so my dear student, for A, for loop A, see for loop A, if you observe means they have given other than subtended angle, the other angle is 90 degrees, okay. So here this sector A subtend an angle we have to find, okay. So other than that angle, if you see means here they have given 90, so we can find angle subtended by this sector A, that is 2 pi minus pi by 2. If I do means I will get the angle subtended by this sector A, okay, that is 2 pi minus pi by 2, that is equal to 3 pi by 2 I will get. So in the place of theta I will substitute this 3 pi by 2. Then what I will get, my dear student, I will get mu naught I by 4 pi, r means 2 centimeter they have given. So I wrote 2. We no need to convert centimeter into meter. Why? Because we are finding ratio here. Both cancel, centimeter, centimeter cancel. So we no need to worry about that. So my dear student, here theta 3 pi by 2. So we wrote mu naught I by 4 pi r plus 2. Theta we found 3 pi by 2. So that is equal to what you will get? You will get 3 mu naught I by 16, my dear student. So I got strength of the magnetic field at the center, okay, at O due to sector A, okay. Then for loop B, if you see means here the loop B, how much angle it is subtended at O, that is 2 pi minus 60 degrees. See, it's loop B subtended an angle theta here, okay, at O. We have to find that. So out, if you see means we have 60 degrees, okay. So that means if you want to find how much it is subtended an angle at O, this sector B, you have to subtract this 60 degrees from 360, my dear student. 360 means 2 pi, 60 degrees means, my dear student, pi by 3. So we will get 2 pi minus pi by 3, that is equal to 5 pi by 2 we will get, my dear student. Now we will find magnetic field due to sector B at center O, okay. See, that is mu naught I by 4 pi r, 4 centimeter, we can write 4, already I told you. So into theta 5 by 2. If you simplify means you will get 5 mu naught I by 32. Now we have to find the ratio of magnetic field due to wires A and B. That is BA is to BB is equal to I got BA 3 mu naught I by 16 is to BB I got 5 mu naught I by 32. That we got 6:5, my dear student. So if you check the options, option B is the answer, my dear student. That's about this session, my dear student. After long time I met you again. From now onwards I will continuously upload videos, not only on JEE, NEET booster also we have. Before I started NEET physics booster, you have supported me very well. Thank you for your support. Like this only you support me every time. If you support me, I can do more videos, my dear students. See, from now onwards I will continuously at least Each week I will upload one video, my dear student, on JEE and NEET. Okay, my dear student. Hope you like the video. If you like means subscribe it and share it, my dear student. Thank you, my dear students. Bye, students.